Hello and welcome to Steph TV. I'm your host, Nick Huzar. I'm also the co-founder of OfferUp. And after watching billions of dollars in secondhand goods exchange hands, I started asking a lot about how my own existence impacts the planet and decided to go on kind of this personal journey by asking really interesting thought leaders about their companies and the interesting things that they're doing to help enlighten us on ways that we can impact the world in which we live. And so today I'm really excited to have Teague Egan. Did I pronounce that correctly?
Egan.
Egan. Okay. Teague Egan, and a really interesting company called EnergyX, who focuses on a really important component of EV technology specific to lithium. And so with that, Teague, I'll hand it over to you to tell us just a little bit more about, your background and like, why did you get into this business in the first place?
Yeah, thanks for having me, Nick. So EnergyX is a lithium extraction and refinery company. And it turns out that lithium has become the biggest bottleneck to the electric vehicle transition. Obviously, Tesla's leading the way with electric vehicles. I think they produced something like 400,000 this first quarter of 2023. And every other major auto manufacturer, GM, Ford, Volkswagen, Mercedes, are all trying to now electrify their fleets. But in order to make electric vehicles, you need really big batteries. It takes about 10,000 iPhone batteries to make one electric vehicle battery. And the most important material in lithium-ion batteries is lithium. So we focus at EnergyX on more efficient and cost-effective ways to produce lithium. And that's what we're working on a day-to-day basis.
And I think when we caught up before, you were talking about this mind that you have to start, right? Maybe can you tell us a little bit more about that?
Yeah, so we're working with several customers that own the lithium resources. So EnergyX doesn't actually own lithium resources. We have developed next generation technology to better extract lithium from the ground. So lithium is found it's a salt that's dissolved into water. It's called brine. And today, the way that the lithium is separated or extracted from that saltwater brine is through massive evaporation ponds. So you'll drill a well, the well will bring up the brine, and then they'll put the brine into these ponds that are hundreds and hundreds of football fields big, literally, up to 10 or 15 square miles, which is bigger than all of Manhattan. And it takes about 18 months for the brine to go through the pond sequence. It goes from one pond to the next pond to the next pond. And the sun evaporates the water, the H2O out, and the salts that are dissolved will crash out or precipitate out. And lithium is one of those salts. So that's the way that it's currently done. At EnergyX, we thought that there was a better way to extract the lithium. Instead of taking 18 months to go through this pond sequence, it takes us, a matter of hours to extract it using technology. In the ponds, they only recover about 30 to 40% of the initial lithium that's pumped up in the brine from the ground. To me, that's a really low recovery rate. They're basically leaving 60 to 70% of the lithium on the table. We recover up to 90% in our extraction methods. And then there's a whole host of environmental concerns that we address, such as 10 to 15 square miles of ponds. You can't just put that anywhere. So that kind of makes a lot of potential lithium resources unviable. So ultimately, what all that means is a more sustainable, more efficient, and more cost-effective way to produce lithium, which is the key, most important ingredient in rechargeable batteries for electric vehicles.
Yeah, and you might know the stat better than I do, but I think I was reading online that lithium requires about 500,000 gallons of water to produce this a single ton of lithium. So it seems like it's like, whoa. So like clearly you can't that's not sustainable, right? Like if you think about where we're going, like you this, it's like a disaster in terms of how you deal with that. So I'm assuming with EnergyX, you're able to do that and using far less water.
Yeah, there's a few different metrics on how you can look at that water statistic. One way to look at it is when they pump the brine out from underground and put it into these ponds, the water is just getting evaporated.
Yeah.
So that's really diminishing the water, the underground water bed that is used for, you know, agriculture in the surrounding indigenous communities. With us, you know, we pump up the brine, we extract the lithium, and then we pump the water back down so it doesn't disturb the water table to, you know, this huge magnitude that currently happens today.
Yeah. Wow. So that's just one aspect, though, I think, of what you do, right? Is just extraction. And it seems like that in alone could be a really interesting business. But I know there's more to what you do and where you want to go. So what are some of the other things that you're focused on?
Yeah, I mean, so to us, extraction is one part of it. Like I kind of simplified it in my initial explanation. But once you extract the lithium from the brine, it's not in battery ready format. There's still a few refinery steps that need to happen. And so while some of our competitors that are in what our space is called is direct lithium extraction, or DLE, they may focus on just that one piece. That's not everything that you need to create an end-to-end solution. So that'll leave a customer kind of either with an unfinished product or looking to other people to find a solution for the other pieces. So not only do we do the extraction, but we do the refinery and conversion to battery grade ready lithium. So that's kind of how we think about it. We also, you know, through some of this research and development, have figured out synergies to next generation batteries using lithium metal, which is one type of lithium. So lithium can come in a few different formats. But yeah, we're focused on new battery chemistries to make higher energy dense batteries, which in layman's terms translates to longer lasting batteries that can either give you more range in a car, or longer lasting batteries in consumer applications like cell phones or computers, things like that.
Man, I love it in my cell phone. Like I'm always getting near the end, especially when I travel at the end of the day. I'm always just ready to die, right? And so I end up getting one of these big this thing will charge my iPhone for a week.
Nice.
You know, 7 days straight, but it's bulky.
What is that?
This thing is really cool. It's called the Char Geek. So like, here's what
Char Geek.
Char Geek.
Can we get that on OfferUp?
No, because they're too new. But they're really cool. If you want to geek out, you can kind of see, like, it tells you how much it's drawing and all that. You can plug laptops into it. But man, longer lasting battery life is big. And then also, you know, I think with EVs, the number one reason that people don't buy EVs, or the number one issue people have with them, is range anxiety. Like, they're always worried they're going to run out of power.
Yeah.
So that's an interesting problem to solve. Now, when you're helping to work with extraction and now you're running it through this refinery process, does it happen there on site, or does everything get? Yeah, I was wondering how you deal with that.
Yeah, we want to do as much on site as possible, because diving a little bit into the numbers here, when you think about a lithium brine, again, brine is just a fancy word for really salty water. Most people think of salt water as ocean water, right? Ocean water has about 3.5% salinity. So like, if you take 1 liter of water and it's divided into 1 million parts, 3.5% of that will be the salt that's dissolved in the water. And then 60 or 96.5% is just H2O, right? The brines that we deal with have up to 30% salt that's dissolved in the water. So on a parts per million basis, that's 300,000 parts per million is salt, and then 700,000 parts per million is H2O, right? Of that 300,000, a very, very small amount is lithium. So we're talking about the absolute best brines in the world have 1,500 parts per million.
Wow.
So overall, that's 0.15% lithium. We look at brines anywhere down to in the really like 200 parts per million range is still an economical brine. So, but 200 parts per million is literally 0.02%.
Yeah.
And then, that's still out of 300,000. There's all these other salts that are dissolved. Most people think of salt as table salt, which is sodium chloride. But lithium comes in the salt form, magnesium, potassium, sulfate, boron, chloride, calcium. They're all dissolved in this water. And the idea is, how do you extract just the lithium away from the rest of the salts?
Yeah.
So go ahead.
I was going to say, and then when you think about these different lithium mines, I'm imagining that the percentage is totally variable depending on where you are, right?
Yeah, every brine is different. So the starting concentration of lithium, like I gave an example of 200 parts per million or 1,500 parts per million, but then all the other salts and the ratio, like those are considered impurities to us, right? We wanted to get just the lithium, and then we can make a battery grade lithium material. We want to get it away from all of those, and it varies from salar to salar, mine to mine. So, a lot of people don't really think about our industry, like what they just think. I owned a Tesla for 5 years before I actually thought about what goes into my battery. That was the reason that I started the company, because I was actually down in South America at the world's largest salt flat, which also happens to be the world's largest lithium resource.
Yeah.
And I'm taking this tour. Like I literally am just on a tour, backpacking through Bolivia. And my tour guide starts telling me about how this is the world's largest lithium reserve. And I was like, holy shit, I have never thought about where my battery or how my battery is made in my car that I've been driving for 5 years. And, this is like the underbelly of global manufacturing, how we get these base or raw materials that go into things like batteries for electric vehicles. And for lithium, there's very, very few other applications other than batteries for lithium. Like, there's some fringe pharmaceuticals, like lithium carbonate is used for bipolar disorder medication. Lithium is used in some glass applications, but batteries are it. And, you may think like, oh, cell phones, computers, like that's a big use case, but that is just a fraction compared to electric vehicles. So like I said, it takes roughly 10,000 iPhone batteries. One electric vehicle.
And the other thing that's fascinating is today we're at about in the US 4% EV penetration, but we expect it to by 2050 to be at 70.
Right.
So imagine that. So you just take your 10,000, you said? Yeah. Okay.
Yeah.
So just run those numbers. Like how do you keep, like you're solving a really interesting problem. And is that when you were there, I always like the founding stories, right? Like when I started OfferUp, I had a room full of stuff and a daughter on the way, stand there in the doorway. I'm like, kill me. It's going to take me forever. Right. And I had no plans of starting this company. And then I just couldn't get out of my head. And like, I got to go do it. So it's really interesting to hear how you were there observing this. And then where did you go from there? Were you like, did you start doing a lot more research or like, yeah.
I started doing research, and, that really opened my eyes to the current process that lithium is produced in today. And that was the opportunity, right? Because all the other battery materials like copper or nickel, cobalt to a much smaller extent, but that's a very, very small percentage of the battery. All the other battery materials have other large applications. Like there's already 20 million tons of copper produced every year. Like it's used in all electrical wiring.
Everywhere. Yeah.
Everywhere. Same thing with nickel. But for lithium, it's not used for anything else other than batteries. So all of a sudden, you had this huge demand spike for lithium, and the way that it's produced today was not only created like hundreds of years ago, like evaporation ponds, like maybe thousands of years ago, but the total global production was created to maybe produce 100,000 tons, and all of a sudden we need multiple millions of tons. So scaling something like that takes a whole new way to do it. You can't scale the existing method. It'll never translate, right? So that's why, you know, what EnergyX is working on, this new way of direct lithium extraction is the main bottleneck to the entire electric vehicle revolution.
Yeah, I think a lot, you know, in the future, you know, especially the next 20, 30 years, we have to reinvent a lot of things, especially infrastructure for electric, but also just energy, period. There's just a lot of things you just, you know, by the way, we're pouring the same concrete mixture we did since the 1700s. It hasn't changed. It seems like you could, right? So I think I think a lot of things are up for grabs and in question, but especially around EVs, just given where it's going, like there's no way we can just do things the same way. It's just not going to work. So, you know, when you think about, you know, we talked about extraction, refinement, and I think you kind of had a third leg, which is around battery innovation, right? Maybe talk about that a little bit more.
Yeah. So like you said, you know, range anxiety is the biggest, one of the biggest reasons that people don't want to buy an electric vehicle. Now, that really only comes into play in certain scenarios. Like typically a person will drive to work and drive home, and maybe drive, you know, max 50 to 100 miles per day. And then you charge your car at night, and, you know, there is no problem with that, right?
Yeah.
But there obviously are like you obviously never want to run out of battery in the middle of nowhere, right?
Especially going on vacation or something.
Yeah, going on vacation. So Tesla has designed a pretty robust charging network. But as more and more electric vehicles come online, you know, there's larger and larger lines. So having batteries that have higher energy density equating to longer range for a car is a really important thing. And as batteries become better, they are not only meant for cars, but long range trucking. Like that's a huge carbon emitter.
Oh yeah.
And then you could even look at other industries like airplanes and things like that. Like transitioning to a completely renewable energy future is going to take better batteries. And it's almost like computers. You know, today you could think about how silly it would be to use a computer of 20 years ago, with like how much memory and RAM and processing power a computer had. But in the moment you think it's good, right?
Sure. Like 8-bit Nintendo.
Yeah, exactly.
Yeah.
So today, you know, my Tesla gets 280 miles per charge, and like that's good. And it's good for what I use today, but there's so much more possibility with creating better batteries that can not only be used for mobile solutions, but also stationary solutions like powering houses or businesses or, you know, buildings and things like that, powering the grid. So EnergyX doesn't have plans to become a battery manufacturer, but we are working on building a better battery chemistry that will then partner with a mass manufacturer to make this thing that, you know, can charge a car for 1,000 miles, or, maybe a phone for 3 days.
Yeah, it's really, to your point, everywhere I look, everyone's retrofitting or doing EV. There's a company here in Seattle that's retrofitting boats, which is pretty dang cool, right? It's quieter, it's got more power to it, like so cool. Because boats are so noisy, and like I wake surf in the summer and I get out there just inhaling exhaust. I'm like, this isn't fun, right? So that's cool. I know they're doing it with planes. I think that the only challenge with the planes is going to be just they're heavy, right? Batteries are heavy, but everywhere you look, like they got the EV motorcycles now. I've seen go snowboarding up here all the time, and they have I've seen snowmobiles now, like a few of these, and so it's just kind of cool to see how people are doing. I have a one wheel. I don't know if you played with those much. It's got the big go-kart tire, and it's basically just an EV pack. It's such a just the innovation. Like, it's one of the coolest toys, by the way, I've ever had. And I think a lot of that's, like you're saying, is like just
hope that it doesn't run out of battery while you're riding it.
I've had that. So I live kind of on a mountain once, and I was turning in this corner, and it just died on me, and I literally went airborne into the bushes, and the one wheel tumbled down into this hill. And I didn't know where it was. It was getting dark, and I had to bushwhack with some sticks, and luckily the light was still on.
Did you not get injured?
Yeah, my elbow and my legs were all bloody.
Okay.
So I had to bushwhack through like some sticker bushes with 2 sticks, and the one wheels are a machine. I had a lot of respect for it. I had just knocked all the mud off, and I rode it, and I ended up riding it home. But I had one of the V1s. I got it on Kickstarter. So sometimes it just decides to turn off when you're riding, and when you're going 20 miles an hour, that's not a good thing.
I think they've solved that problem, but V1's definitely, yeah.
I know, that's why I like the e-foils, right? But those are still new too. A lot of them have they're pretty new. And my learning lesson from having the V1 of anything is like, you're gonna have a lot of issues with it, right? So like so I'm kind of waiting on one of those, but I think the new one wheels are pretty dang cool.
Yeah.
Well, I mean, maybe talking a little bit more about the future. Like, what are like your plans over the next 10 years? Like, what gets you excited? Where do you want to take your company? And let's dig into that.
Yeah. So for me right now, it's all about scaling our lithium extraction and refinery technology, as well as our battery initiative. We piloted our DLE technology last year. So we had an in-field pilot in South America, and that was really an MVP, a minimum viable product that, when you're doing any sort of manufacturing, it's very different than, say, a software business, like an app or something like that. We're actually like working with chemicals every day. We're working with large machinery, and taking something out of the lab setting that we do experiments in, and test tubes and stuff like that, and put something into the field that is in harsh operating conditions, and running that 24/7 for a long duration. That's a huge milestone for any startup company, and that's the milestone that we crossed last year. So I founded EnergyX in 2018, and then all of 2019, 2020, and 2021 we were in the lab. So 3 years developing these technologies, and then in 2022 we put our first pilot in the field, ran that for 5 months, 24/7. And this year we're focused on scaling that. So taking something that could produce like 3 tons of lithium per year up to like 100 tons. So moving from a pilot to a demonstration scale plant. And that's really the last proof of concept stage before a full commercial plant that can produce 10, 20, 50,000 tons of lithium per year. So as we look into the future, 2024, 2025, 2026, hopefully we'll be building these large commercial plants that are producing tens of thousands of tons of lithium, and then selling that to cell manufacturers that make the batteries, or the auto manufacturers themselves. And then on the battery side, we do the same thing in terms of scaling. So we started with small coin cells. They still sell small coin cells for some applications in like Walgreens and stuff. But that's how you start screening materials that are inside the batteries. So we use our own proprietary formulation and chemistries of different quantities of lithium mixed with different materials inside the coin cell. And then once we have a coin cell that is cycled hundreds of times, we put it on what's called a cycler, and it charges it and discharges it, every 3 hours. So one charge will be 3 hours, and then a discharge is 3 hours. It's called a C rate.
What are you trying to figure out in that process?
How many times it can cycle? Because if it dies after 30 cycles,
that's
not a good chemistry.
Yeah,
you need a battery to cycle like at least several hundred times in a coin cell.
Okay.
And then you start building bigger cells, either pouch cells, which is like something that goes in your iPhone, or cylindrical cells that looks like a AA battery but bigger, maybe something like this. So this is called a 2170, and then larger ones are called 4680s.
I got a bunch of them in here. See,
nice.
It's like just full of them.
Yeah, that probably doesn't have these cylindrical cells though.
No, one of them looks like a big long bat. It kind of looks like the first one you pulled out.
But is it round?
Yeah, it's round.
Okay. So once you get past a coin cell, then you move up to a pouch cell or a cylindrical cell. And we do pouch cells, so we'll do a single layer pouch cell. And then you start getting into multiple layer and longer pouch cells. So we're going through those iterations and that scaling on the battery side. And we've had some very exciting results in both initiatives for EnergyX.
Well, that's awesome. I always think the hardest, when I reflect back even on OfferUp in the early years, getting a product to market, okay, that's hard enough. And anyone that does that, kudos. Then it's about how do you scale? And then it's a whole nother problem. I think it was the hardest problem to figure out. And, we stayed in Seattle for 1 year at least before we went anywhere else. But once you figure that out, like you're doing, then you can kind of, okay, now I'm going to rapidly scale. And that comes with a whole new set of issues and challenges that I'm sure you'll face. And so it's like when Elon Musk was, I don't know if he's still sleeping in the office maybe, but when he started mass producing Teslas, right? Okay, everyone likes Tesla, but now we can't keep up with the demand. And so he had to rethink car manufacturing. And everyone's, remember all the big automotive guys poo-pooing, it's like he's not going to figure this out. Well, he did, because he's Elon, and he's in the office obsessing over every single process there. And it's awesome that he figured that out, right? He figured out, okay, how do I produce EVs at scale in a profitable way? And now I feel like he just looks at everyone in the rearview mirror. It's like, oh yeah, sure. Everyone else is building EVs too, but he is so far ahead in terms of innovating, not only on how you think about an electric vehicle, but also I think he's rethinking a lot of the processes that it takes to make cars.
Yeah,
so
absolutely. He's focused on the machine that makes the machine.
Yes. Yeah. So it's really fascinating. I'm super excited. I remember in my 20s, I always thought like the Carnegie of our time was going to be somebody that rethought energy. I didn't think it was going to, Elon was going to be a part of that at all, but I'm still very bullish on that. And like, it's just so cool, like this time that we're in, to see kind of all this evolution and things that are changing, just like anything else, though, I just want it to all happen faster.
Yeah. Right.
Well, cool. I'm trying to think of anything else to dig into. This is a really fascinating topic. I could geek out on, electric stuff all day long. Anything else kind of we're talking about? I know we talked about the history, kind of why you got into this and what you're excited about.
No, I mean, I think that, for all the viewers, I just think that it's worth, if you're not already interested in lithium based off what we said, it's definitely worth taking a deeper look into. I can just speak for myself. I used to only think about the consumer level. And then when I started learning about how these things are actually made, going down into the manufacturing process, it just opened up a whole new world. And like, these are some companies that, you know, are huge 10, $100 billion companies that like you've just never even heard of, right? Like,
Yeah.
we know about like LG or Samsung or Panasonic because they also have consumer facing brands, right? Like a TV, like you go buy an LG or a Samsung TV, right? But the biggest battery company in the world is called CATL, Chinese company, that, you know, probably not many people have heard of, right? Or one of the biggest battery component manufacturers that makes the cathode is a company called POSCO in Korea. And like, no, you know, this is a company that does 60 billion in revenue a year, through cathode, but also steel manufacturing. And like the majority of people have just never heard of POSCO before. So it's a super cool place to be right now. And, you know, EnergyX is kind of on both sides. Like our technology isn't consumer facing, like we're not a B2C company, but, you know, we want to educate the public about this stuff so that, you know, the conversation expands and ultimately it can positively push forward the energy transition, and reduce carbon emissions to stop climate change.
Yeah. Well, I think it's awesome what you're doing. And thanks for talking about such a, like you said, when you started this company, such an important component that we all take for granted, right? Something that powers all of our batteries. And we don't even think about like, oh, what the hell does that actually do? You reminded me of one last thing. When I was a kid, I actually built a battery. You can do this, right? You can do this with little kits and you can add a little salt in there and you can watch it start to happen. And it's kind of fun. So for anyone that happens to be watching this, like maybe something to do with your kids to think about, to talk about just batteries in general. But really appreciate you for being here. And I think it's such an awesome company and I'm excited to just kind of follow your journey over time. So thanks for giving me a little bit of time.
Cool. Appreciate it, Nick. Thanks for having me on.